An uninterrupted series of satellites has collected sea level measurements for nearly 30 years. And now, a joint U.S.-European effort will launch the next spacecraft to continue this legacy of monitoring sea surface height. Welcome. I am Marina Jurica with NASA's Jet Propulsion Laboratory, and we are here at Vandenberg Air Force Base in Central California, where we are launching the Sentinel-6 Michael Freilich satellite tomorrow. I am your host today as we bring you a closer look into the science behind this mission that will continue to help us understand how our oceans are changing. Following this briefing at 2 p.m. Pacific time, we'll be back with another panel to discuss the readiness of the spacecraft, the launch vehicle, and the range for tomorrow's launch. This has been a true international collaboration among several agencies, which you will see represented today, in a first joint Earth mission teaming NASA and the European Space Agency, along with other partners, the European Organization for the Exploitation of Meteorological Satellites, or EUMETSAT, the National Oceanic and Atmospheric Administration, or NOAA, and the French Space Agency, CNES. This Sea Level Scout will collect the most accurate data yet on sea level and how it changes over time. During this briefing, we are taking questions from the media via the telecon line. Press star 1 to get into the queues, or via social media with the hashtag SeeingTheSeas. As we are social distancing, I will introduce you virtually to some of the key scientists who will be involved with the mission hands-on, studying the data coming from the Sentinel-6 Michael Freilich satellite and distributing it worldwide. On our panel today, we have NASA's Earth Division Director, Karen St. Germain, Craig Donlin, the European Space Agency's project scientist for this mission, Remco Charroux, the EUMETSAT project scientist for Sentinel-6 Michael Freilich, Josh Willis of NASA's Jet Propulsion Laboratory, NASA project scientist for this mission, Deidre Byrne, oceanographer at NOAA, and lastly, Luann Thompson, a University of Washington oceanographer who is part of the science team. A reminder to the media, you can ask question by pressing star 1. For anyone watching who would like to submit a question, you can do so by using the SeeingTheSeas hashtag. We will begin with NASA's Earth Science Division Director, Karen St. Germain. Welcome, Karen.
Thank you so much, Marina. It is great to be here. I could not be more excited for our launch coming up tomorrow. The Sentinel-6 Michael Freilich launch is exciting to me for really 3 reasons. The first is, of course, it's my first launch as the NASA Earth Science Director. But perhaps more importantly is the impact this satellite is going to have on our understanding of our Earth system. And the third reason is really the people behind this mission and what it took to make it happen. So let me start with the impact that this mission is going to have. You know, our Earth is a system of intricately connected dynamics between land, ocean, ice, atmosphere, and also, of course, our human communities. And that system is changing. And because 70% of the Earth's surface is ocean, the oceans play an enormous role in how the whole system changes. And these global changes are, of course, creating both risks and opportunities for our human communities. And at NASA, what we do is we use the vantage point of space to get a global view of the Earth. And in this case, Sentinel-6 Michael Freilich is going to give us a global view of the sea surface height. We will use that along with our models and our predictive capability to really understand how the changing sea level is going to impact coastal communities and weather worldwide. As you'll see in this next chart here, Sentinel-6 Michael Freilich is the newest addition to the NASA fleet, and you'll see that many of the satellites in the NASA fleet were developed collaboratively with international partners. And that's important because the challenges we're facing are truly global, and it's taking a coordinated effort around the world in space agencies to make all of the observations we need to make to understand how our climate is changing. The Sentinel-6 Michael Freilich will continue a nearly 30-year record, along with its twin that will launch a few years later, will continue our record of sea surface height observation well into the next decade. It's a critical observation for a number of reasons, but its power is really unleashed when we combine our altimetry observations, or the sea surface height measurements, with the observations we get from the other satellites in the NASA fleet and the international fleet. In the next chart, you'll see that it's really when we combine altimetry observations with observations from our gravity missions and so forth, that we can not only see that the sea level is rising, and that's the top curve you see on this chart, but we can also tell how much of that change is coming from melting ice sheets and glaciers, and how much of that change is coming from thermal expansion of the oceans themselves. In other words, when the oceans warm, they expand. So the middle chart here, about 2/3 of the sea level rise that we're seeing is due to the melting ice sheets and glaciers, and 1/3 is due to that expansion. So that's the kind of power we get when we combine observations. Another is when we talk about hurricanes and tropical storms. So sea level rise or sea level observations can tell us where there's warm water in our oceans. And this is particularly important this year as we're seeing a record-breaking hurricane season in the Atlantic. When a tropical storm passes over warm water, we can expect that it may rapidly intensify. And that's really critical for warning our coastal communities. And we get that when we combine the altimetry observations with our weather satellites. So it's this combination, it's this fleet that's observing the entire Earth system that really gives us the insight into how the whole Earth system is changing. I mentioned partners, and this partnership with ESA is a first for us at this level in the Earth Science Division within NASA, and it's been a terrific experience. This team has worked through all the challenges of COVID to get us to where we are one day before launch. This is also a special mission for me because Mike Freilich's name is on the side of this satellite. Mike was my predecessor as the Earth Science Director. He was also a leader in the field, a mentor and a friend to many of us. And so it's an extra special day when we will see this satellite launch, the satellite that he worked so hard to put in place. So it's a great weekend for a launch, and we're looking forward to it. And I'm going to pass off now to my good friend, Dr. Craig Donnellan, who's the ESA project scientist. Craig?
Thanks, Karen. Could I have my first slide, please? I think we both agree that Earth from space is beautiful. I mean, its glory and its technicolor is seen in this Copernicus 2 image of Ari Atoll in the Republic of the Maldives. I mean, in one picture, both the majesty and the fragility of our world is revealed. But sea level rise is a direct threat to the very existence of Ari Atoll. And it also threatens major cities with increased flooding, including New York, London, Amsterdam, Tokyo, and more. It's estimated that about 2 to 3 million more people are exposed for every 1 centimeter rise in sea level. Next slide, please. As you mentioned, our Earth system is changing. The dynamic balance that has persisted before the Industrial Revolution has been upset by the almost instantaneous combustion of huge reserves of carbon as our society has developed. And we see evidence of this dramatic change in many different measurements and events around the world, but they all point in the same direction. The Earth is warming. And the greatest indicator of this Earth system imbalance is sea level rise. It's because it integrates the total impact of global warming that's dominated by the ice sheets melting, the thermal expansion of the seawater, and changes in the terrestrial water storage. Next slide, please. As Karen mentioned, sea level rise is not the same everywhere. And rather than relying on a few local tide gauges dotted around the world's coastlines, we need a global tide gauge in space to monitor the complexity of what's going on and collect evidence of these changes to make the best decisions for our future world based on scientific evidence. Next slide, please. Now, Sentinel-6 Michael Freilich is a new satellite to do just this, with enhanced continuity compared to the previous missions that have flown in this orbit. We have a brand new synthetic aperture radar altimeter and a microwave radiometer that really are at the heart of the mission, measuring sea surface height referenced to the same datums as the global positioning satellites that are used in your smartphones. And many people ask about the shape of this spacecraft, our little house in space. Well, Sentinel-6 has a design heritage in the European Space Agency Cryosat satellite. And this allows us to put solar panels directly on the side of the satellite, limiting the need for big solar wings that have to move. And that makes for a very stable satellite design, which is really important for a satellite altimeter mission. Next slide, please. Now, to make the measurements, the satellite uses a radar pulse that's sent down and reflected off the sea surface. And we time the time of that travel and return. And we receive a waveform. And from this waveform, we can determine the sea surface height from the radar range, the significant wave height from the slope of the leading edge, and the wind speed from the surface roughness of the waves on the ocean. And people will talk about that a bit later. And the timing arrangement that we have on board the spacecraft allows us to exploit the Doppler characteristics of the radar, allowing us to bring a whole bunch of measurements together at the same point on the Earth's surface and average those, and at the same time reduce the along-track resolution of the instrument to just about 300 meters, which is, compared to 2 kilometers for previous missions, pretty good. We can do both the low resolution and a high resolution mode at the same time, which is really important because by introducing new technology into the time series, we don't want to destabilize that time series. So we need to look at both types of measurements, the old ones and the new. And in order to get our accurate measurements of sea level rise, we average data over about a 10-day period, taking all of the measurements over the global ocean to give us the sea surface height from which we can then compute sea level rise. Next slide, please. Now, Copernicus is the world's largest operational Earth observation system. It's implemented by the European Space Agency on behalf of the European Commission, together with EUMETSAT, and it includes a fleet of complementary satellites working together in synergy, particularly with ocean models and allowing us to do climate and ocean forecasting. But these work like a painting. Each satellite has additional color that we can use to paint a wonderful scientific picture of the Earth. But Michael Freilich goes further, and this really leverages the special and unique relationship between NASA, NOAA, EUMETSAT, and the European Space Agency, together with the European Commission. And it really follows the collaborative principles championed by Michael Freilich himself. And so tonight, all of the dedicated mission teams working around the world are really looking forward to the launch of Michael Freilich. It's going to be our new star in the sky, allowing us to deliver the best quality measurements of sea level rise, ocean waves and winds to make the best decisions today for everybody in the future. So I'll hand over now to Remco Charoux from EUMETSAT, who's the EUMETSAT mission scientist. Remco, over to you.
Thank you, Craig. Well, Copernicus Sentinel-6 mission is going to be very exciting for EUMETSAT. It's actually the first radar altimeter mission that EUMETSAT has been leading from the start. We have designed and set up the ground segment and our processing chain, and now we are ready in a few days from now to take over the operation of the Sentinel-6 satellite. Then we will download the first data from the satellite, and we will from that create the most accurate sea level, wave height, and wind speed measurements ever. Sentinel-6, as Craig already showed, fits nicely into this constellation of Copernicus missions. Apart from Sentinel-6, there are actually 2 other satellites with altimeters on board called Sentinel-3A and Sentinel-3B. First slide, please. Those satellites are also operated by EUMETSAT from here in Darmstadt. And these are very complementary missions. As you can see in the slides, the purplish colored ground tracks are very dense. They are those from Sentinel-3A and Sentinel-3B, and they can observe the smaller scale features, like ocean eddies. Sentinel-6 continues the heritage of 30 years of its predecessors, making a more coarse pattern here in white. It will focus on the larger scale features, like El Niño, and it will very accurately trace sea level rise, both globally and regionally. After launch, we will have a year of commissioning that focuses on running the processors and analyzing the data that we have processed. We will check the measurements together with our partner agencies, but also with a number of experts in the field. We can compare the data to ocean models, but most importantly, we can compare it to its predecessor, Jason-3. And to facilitate that, the two satellites will be flying only 30 seconds apart on the same orbit. That means that they will basically see the same ocean conditions. And that, of course, makes comparing the measurements much better. And as Craig already indicated, because we have also a new technology, this is very important. We will do this for a whole year to make sure that we have a full continuity. Once we are confident that all the data is good, then we will send it to all of the users. This will include meteorological agencies, science users, but also anybody who is interested in the data. As soon or as long as you have an internet connection, you can get the data for free. Now, after that year of commissioning, Sentinel-6 will become the reference mission. That means it's the reference for all other altimeters, for sea level, wave height, and wind speed. Now, Jason-3 is then available to be moved in a slightly different orbit. It can, for example, just like the previous missions, then be retired into a slightly different orbit where it can do something else. For example, map the sea surface very accurately in a very dense pattern and in very high detail. And since the sea surface maps after the gravity field, it actually highlights seamounts and troughs and also ridges deep below the ocean surface. And scientists have been able to use this data to make a very detailed global map of the sea bottom. Still, we know the topography of the moon better than our own ocean bottom. And still, thousands of seamounts are to be detected. Next slide, please. In the meantime, Sentinel-6 will keep continuing this 30-year record of sea level rise. In this plot, you see 12 altimeters that have been flying during the last 30 years. And the pattern that is revealed is similar between all of them. You see a rise of as much as 9 centimeters over the last 30 years. And we can even see a slight increase of the rise over the last decade. So this mission is going to be very important for everybody, particularly those in coastal regions. And it's very satisfying for me to have been included in this mission. I've been working for 30 years with satellite altimeter data and the last 7 years on Sentinel-6. So it's a pleasure to see Sentinel-6 Michael Freilich be launched, and then after that see the first data coming out. And George, I hope you feel the same.
I certainly do. Thanks, Remco. Thank you also for all your work over the years. I know it's been a long haul for you. Well, Sentinel-6, what can we say about it? It's the satellite so nice we built it twice. That's right. In fact, there are actually two Michael Freilich, not two Michael Freilich satellites, but two Sentinel-6 satellites. The first one, Sentinel-6 Michael Freilich, will launch tomorrow, and in 5 years from now, will launch its successor, Sentinel-6B. Now, this is a huge deal for us climate scientists because it means we get to look at the oceans for a full 10 years in an unbroken record. And it's the first time we've been able to build two in a row so that we can launch them back to back and extend the record much farther than we've been able to so far. Now, the record of global sea level rise actually, as Remco just showed, goes back to the early 90s. And what's interesting about it is that you can see the rate of rise is actually increasing. So in the 90s, sea level was rising at about 2 millimeters per year. In the 2000s, it was more like 3 millimeters per year, and now it's more like 4 or close to 5 millimeters per year. So we're watching the rate of sea level rise increase right before our very eyes, and it's satellites like this that allow us to do it. Now, the rising ocean is important for climate change because over 90% of the heat trapped by greenhouse gases that we release into the atmosphere is actually going into the oceans. So we often think about it as global warming, but really it's ocean warming. The oceans are the really big player in terms of absorbing heat from the climate system. So the oceans warm, the water expands. That's about 1/3 of sea level rise, as Karen mentioned earlier. The rest is from melting glaciers and ice sheets that are reacting to the warming environment too. So these missions really give us our most important yardstick for measuring climate change and how it's playing out on the planet. But they don't just measure climate change. In fact, this is a huge impact. As Craig mentioned, hundreds of millions of people will be affected by sea level rise in the coming decades. And right now, as climate scientists, we're really good at predicting global warming, but we're not so great at predicting sea level rise. And our best tool for predicting the next 10 or 20 or 30 years of sea level rise is what's happening today and what's happened for the last 10 to 20 to 30 years. So these are really important tools for climate. And of course, the oceans, which cover more than 70% of the planet, play a huge role in many aspects of our climate. And I think we'll hear a little bit more about that later. But in the meantime, Sentinel-6 also has a new toy. I think we have an animation. There's a radio occultation receiver on Sentinel-6. So this is an antenna that looks forward as the satellite flies around the Earth. And as it looks forward, it sees GPS satellites coming up above the horizon. And as they do, the signal from the GPS satellite passes through the Earth's atmosphere and skims off of it. As it does, it slows down, and the satellite measures how much that slowing happens, and that actually bends around the Earth, as you can see on the rear-facing antenna right here. Now, we use that information to actually figure out the temperature and the humidity of the atmosphere, not just at one location, but as a function of height throughout the atmosphere. So you can actually get a profile of temperature and humidity, which is really cool. It's really great for numerical weather prediction. And in fact, it's so cool, I think I have to put on my sunglasses before I introduce our next speaker, which is Deirdre Byrne, NOAA oceanographer. Stay cool, Deirdre.
It's Climate Elvis. Yes, so I wanted to talk a little bit. It's obvious, it should be obvious to you guys now, that Sentinel-6 has a really important climate mission, but we're getting the data in real time, and at NOAA, we're excited also about using these data to improve our real-time ocean products, which is something we call nowcasting. And in particular, I'm going to talk about the potential to improve predictions of hurricane intensification. So hurricanes take energy from the ocean surface waters. A warm ocean under a hurricane will tend to spin it up, and a cool ocean under a hurricane will tend to dampen its strength. So Sentinel-6, when it's added to the constellation of satellites already flying, is going to improve the accuracy of our near-surface ocean heat content products, which is something that comes out every day and is used by hurricane forecasters. So it's important for this application to realize that because Sentinel-6 is a radar instrument, it's an active instrument, it can actually see through the clouds, which is a huge advantage for hurricane work. Now, I just want to mention that hurricanes have always been a big deal, but because of global warming, they're becoming more powerful, They're wetter, they're slower moving, they're intensifying more rapidly, they're spinning down more slowly, and now the conditions that spawn hurricanes are occurring over a larger area of the ocean. So that makes it even more critical to have accurate hurricane predictions. Could I have my first image, please? So what I'm showing here is, people are becoming aware of this. This actually hit the newspaper, the daily newspaper, which was a thrill to me. And the figure on the right is showing you the upper ocean heat content on October 7th as Hurricane Delta was passing over, and there's a little track there of the hurricane. And as it crossed that red warm patch in the Caribbean, the hurricane spun up from having a top maximum sustained winds of 20 knots to 120 knots. So that's a really critical tool for us. It's another another tool in our toolkit for better hurricane prediction. Could I have my next image, please? And as Craig mentioned, ocean surface roughness and significant wave height are part of the radar waveform that come when you're making measurements of sea level. But I want to emphasize that the significant wave height is actually a useful measurement in and of itself. So at NOAA's Ocean Prediction Center, forecasters use the significant wave height to provide marine warnings and predictions. As real-time data, this information is particularly useful for ship routing around storms. In this picture, this is a screenshot from a forecaster's actual screen. The forecaster's warning mariners about waves reaching between 45 and 57 feet high in an intense Pacific storm. So the real-time data have an essential mission in protecting property and saving lives. And used in retrospect, significant wave height is also useful for things like risk assessments in the marine insurance industry. Could I have my next figure, please? I also wanted to mention that NOAA brings significant in-water assets to enhance the value of this mission. In particular, we maintain a large network of tide gauges around the U.S. coast because land can experience forces like uplift and subsidence and erosion. Tide gauges are essential to link the satellite record to what's going on around the coast. And our other big in-water measurement system that's critical for the Sentinel program is the Argo program. Argo probe floats are robotic probes. They drift around in the ocean and they cycle up and down, making what we call profile measurements. And those profile measurements are an essential tool in translating the sea level rise measured by Sentinel-6 into measurements of ocean warming, but they're also essential to the hurricane prediction tools I mentioned earlier. Most recently, we've extended these profiles into the deep ocean with a program called Deep Argo, and those probes are being deployed in areas that have been seen to be experiencing rapid change in their deep waters, most of which are of polar origin. I want to emphasize Argo is a truly international program with many, many countries participating, and there are currently around 4,000 Argo probes in the ocean at the moment. But the U.S. plays a big role in that. I believe we've funded about half of those probes. And as you can see here in the NOAA Argo lab in Seattle, we calibrate the probes and deploy them off our ships. That's the figure on the right. And all in all, that program has been a huge success and is a critical partner to go along with the Sentinel-6 satellite and other altimeters flying. Could I have my next slide, please? So as Craig already mentioned, I want to mention that NOAA and our partners, NASA, ESA, and EUMETSAT, operate many kinds of satellites. So we measure ocean color, ocean surface temperatures, ocean winds, and these types of information are synthesized into products that we use for ecosystem monitoring, we use for prediction tools for harmful algal blooms, and we use them to drive ocean models like the one you can see in the figure. And those models feed into weather predictions. So just having one additional satellite in the mix is going to increase the frequency and density of sea level measurements available. And in particular, that's been shown to be critical for accurate prediction of ocean currents in coastal waters. So in addition, Sentinel-6 is exciting to us because it is flying new and better instruments. And there is a possibility of using new techniques on the data that would get us information just a little bit closer to the coast. So it's just a few miles, but every little bit helps. So that's a promising development for providing more accurate and timely coastal predictions. So ultimately, to me, the Sentinel-6 missions are exciting because they're going to allow us to provide better information to coastal communities. That's 40% of the U.S. population. And they're really experiencing the brunt of a lot of climate change, inundations, stronger hurricanes, things like that. And now over to Luann.
Thanks, Deirdre. So I want to talk to you about other applications of sea level to the study of the ocean's role in climate, both climate variability and change. And in particular, the continuity of the satellite mission is really important for climate studies because we need to know how climate has changed over long periods, especially if we want to know what controls monthly to year by year changes in climate. So the first example I want to talk about is El Nino. So go ahead and show the first slide. So many of us have heard about El Nino, and it has impacts all over the globe. And it initiates in the tropical Pacific, where the tropical Pacific warms, and then that sets off reverberations through the atmosphere that then impact areas of the planet that are far from the tropical Pacific. I'm sitting in Seattle, and right now we're experiencing a very wet and cold fall and early winter. And you can see that orange circle over Alaska and the Pacific Northwest. That shows drying and warming during El Nino. We are in the middle of a La Nina, which is the direct opposite of El Nino. During El Ninos, you also have really dry weather over Indonesia and the rainforest there, and you often see very large fires. But this is all coming from the tropical Pacific in that green area. So now we're going to look at what sea level tells us about what's going on with the tropical Pacific with the next slide. Can you give me the next slide, please? There we go. So this is sea level from 2015 to 2016, and you see this red, which indicates high sea level. Now, what does that mean? What that means is that there is a local rise in sea level, and in fact, it's almost up to a meter in some places in the tropical Pacific. Now, that doesn't sound like that much, but it represents a huge amount of heat in the ocean. If we think about water can hold a huge amount of heat, and in fact, when I go to bed at night and my feet are cold, I use a hot water bottle, not a hot air bottle. So that about a meter or so, a little bit less than a meter of sea level rise actually represents warming of the ocean from the surface down to several hundred feet or 100 meters. That's a huge amount of warm water. And with that warm water, we can tickle that atmosphere or even push it a little bit and then see those impacts far from the tropical Pacific. So sea level is really important for understanding what controls El Nino and La Nina and the transitions and can potentially help us predict it. So we're going to go ahead and start talking about ocean currents with the next animation. So the other thing about sea level that Deirdre mentioned is that it actually gives us a really accurate representation of the surface currents in the ocean. So here's an animation of surface currents, and you can see the Gulf of Mexico, where you see this big eddy going around, and that's where Deirdre was talking about the impacts of sea level rise on hurricanes. And then you see the Gulf Stream coming up the eastern seaboard of the US and going out into the North Atlantic. The really interesting thing about sea level is that the sea level doesn't ride down, the currents don't ride downhill, they ride along the hill. And the steeper the hill of sea level, the faster the currents. So that animation ended up in my favorite current, the Gulf Stream, which is key to my research right now. So let's go on to the next slide and start talking about the ocean's role in climate and how it exchanges heat with the atmosphere. Now, the global warming signal from the excess carbon dioxide in the atmosphere gives us about an excess of 2 watts per meter squared over the ocean. Now, if you look over the Gulf Stream, once again, east of the US, you might be able to see that the amount of heat that's leaving the ocean and going to the atmosphere is 2 orders of a magnitude bigger. That's 200 watts per meter squared. And that also represents an area of the ocean that has large variations in sea level or the heat content of the upper ocean. And with that information of how that heat content is changing, by observing sea level, we can also learn things about how we can use this huge heat capacity ocean to actually understand what controls weather over Europe on timescales from a month to several years. So these sea level measurements are not just about what's going on around the coast, but they also tell us about what controls the climate over months to years, and in particular, what the role is for controlling this climate variability and change. Okay, I'll send it back to you, Marina.
Thank you so much, Luann. We are now ready to take media questions. Remember to press *1 to get put in the queue, and please direct your questions to one of the panelists that we just heard from. We're also taking questions through the Seeing the Seas hashtag on all social media platforms. So right now on the phone, we have Elizabeth Howell with space.com. Welcome, Elizabeth.
Hi, and thank you so much for taking my question. This is probably for Deirdre. If I was a member of the public following this mission, what kind of maps, charts, or other data products could I look forward to for Sentinel-6? And also, about when will they be released?
Well, we'll be folding the Sentinel-6 data in with all of the other altimeters in the family, so you really wouldn't see from our information products a special Sentinel-6 map. We take in all the available information and we use it together, which is not to say you can't go get the Sentinel-6 data if you want it, but just from the user end, it'll be folded in.
All right, thank you so much for that. And now we will head over to the hashtag Seeing the Seas social media questions. Our first question comes from Caribbean GIS on Twitter asking, will hashtag Sentinel-6 data be made available to the public on G or other portals? Question. Maybe Remco can answer this.
Yeah, thank you for the question. In fact, if you really want to get to the data, first you need to wait a bit. As I explained, we first want to analyze the data before we're going to release it to all users. But we do that over the next year. We'll start that in around 6 months, and all the products will be available by the end of the year. You can get it from EUMETSAT. You can go to the EUMETSAT website and find the Earth Observation Portal, the EO portal. You set up an account, and from that onwards, you can download the data once it's available. It's very simple, and I hope that you will enjoy the product. Also, as Deirdre mentioned, of course, we also distribute this data to other agencies that then make their own products, like NOAA is doing, but also, for example, the Copernicus Marine Environmental Monitoring Service, CMEMS, will be doing. ECMWF, the European Center for Medium Range Weather Forecast, will be. So Sentinel-6 will start to be incorporated in a lot of the user products that are created by other agencies as well.
And I think that's what makes this product so amazing, is that everybody has access to it across the globe, which is really incredible. We've got our next question from Twitter from Ave Valencia. And the question is, why is its twin satellite being launched 5 years apart? Would you like to take that, Josh?
Yeah, thanks for the question. We need to get as long a record as we can of sea level. We've been measuring sea level since the early 90s with these missions, and each one has just barely launched in time before the next one has aged and stopped working. So what's amazing about this satellite is really two things. First is that we're launching it while our previous satellite, Jason-3, is still healthy and young. And then the second is that we'll have another satellite in 5 years. As Sentinel-6 Michael Freilich starts to age, we'll be able to launch Sentinel-6B to take its place and extend the record a full decade. And as I said before, every decade is like a whole new rate of global sea level rise that we have to measure all over again. Sea level rise isn't going to go away anytime soon, so we have to keep measuring it, and the longer the record, the better.
Thank you, Josh. Next, from Instagram, Cedric asks, how long will Sentinel-6 operate for? Karen?
Sure. So each one of the satellites, Sentinel-6 Michael Freilich, as well as its follow-on, Sentinel-6B, we anticipate will live about 7 years. So that's how we get to, by launching them 5 years apart, that's how we get to the decade-long record that Josh just mentioned.
Great, thank you, Karen. And now Denzel on Periscope asks, what part of the ocean is covered by this new satellite that wasn't before? Craig, would you like to take that question?
It's a really good question. The part of the ocean that has not been covered before is the high resolution part of the ocean, which we can get at by using our synthetic aperture radar technologies. And this means that we can get down to just 300 meters in the along track direction. And in certain parts of the ocean, for example, we can be in the eastern basins of the Southern Pacific, how long-wave swell rolls in from the Antarctic and the Southern Ocean currents, and we can see that in the SAR data, and that hasn't been visible before in the low-resolution measurements that we've had in the past. The orbit stays exactly the same as the predecessor missions because, as Josh mentioned and Karen mentioned, we need to keep our spacecraft in that orbit to maintain the same measurements for the long duration. That's how we get the precision of our sea level measurements. Back to you.
Thank you, Craig. Now, Astro Girl on Periscope asks, how much does seawater rise each and every year? Luann, would you like to take that?
A few millimeters a year. So on accumulated over the record, we have about 9, over the last century, we have about 9 centimeters of sea level rise. And it's just that sea level rise is going to continue to accelerate over time.
Yes, thank you, Luann. At Moon to Mars Quest on Twitter asks, 2020 has produced a robust hurricane season in the Atlantic Basin. Will future active hurricane activity like this year's affect the general average sea height when compared to the baseline? Deidre, would you like to take that?
I don't see the hurricanes affecting the sea level. It's more that a higher sea level is indicative of more heat that's available to feed into the hurricanes. So it's the other way around, if I got the question right.
Yes, thank you. Lakin on Twitter asks, what is the deepest sea level measured so far by the satellites that have come before Sentinel-6? Josh, would you like to take that?
Sure. The satellites measure how tall the ocean is, but they don't, and they really tell us that relative to the center of the whole planet. So what we're watching is how the oceans grow over time. If you think about it, it's really amazing. More than 70% of the planet is covered by oceans, and all of that is rising. So we're literally watching the shape of the planet change before our very eyes, and that's what these satellites are really so good at. Thanks, Marina.
Thanks so much, Josh. And thank you so much for media and social media who have contributed today to this really awesome briefing. We all learned so very much. Thank you for your questions, and thank you to our panelists for joining us here today. The U.S.-European Sentinel-6 Michael Freilich satellite will launch from Vandenberg Air Force Base tomorrow morning at first attempt 9:07 a.m. Pacific time. For more information on the satellite, go to www.nasa.gov/Sentinel6, and you can also follow us on all social media platforms at NASA Earth to keep up with this mission and all the Earth missions that we are a part of. Thanks so much for joining us today at NASA Earth Science. Your home is our mission. Thank you for watching.